Okay, good afternoon. Hi, everybody. Anyway, I'm glad we got this conversation going. I completely forgot that we had to go live at this time, so it's really good. But anyway, Chris, as I was saying, those are all my thoughts on the current presidential election, civil liberties, gay rights, women's rights, and Ukraine. It was good having that conversation. Now let's get back into what we were going to talk about, which is you say I saw you have an O'Reilly training, and I was kind of excited to talk about that because frankly, anything from O'Reilly is good. And so also you're my old friend. Can you introduce yourself for the audience so that I don't butcher it, please?
Oh yeah. So I'm Chris Richardson. What else can I say? Me, I've been building software for a really long time. And
what do you try? Just phone it in.
Yeah.
You should just.
So what am I known for? So I mean, way back, I wrote the book Pojo's in Action. So that was all about building applications with Spring and Hibernate back in like 2006 when they were a novelty. Which is, that is so long ago, right?
It is. 18 years. It's a long time. That book is now old enough to drive and vote in America. So
I hadn't thought about it in those terms. I should have encouraged it to register as a voter.
And then in 3 short years, it'll be able to imbibe alcohol. So
yeah, that would be scary. Drunk Pojo's in action.
Like Drunken Master or something. Yeah, that's good.
Which actually, interestingly, I mean, even though the book is sort of, obviously it's quite an old book, that, just based on conversations with people, there's still some quite relevant things in that book. Like specifically the whole topic of database concurrency. There's topics like isolation levels, implementing optimistic locking, and then kind of locking in user workflows like pessimistic offline lock and optimistic offline lock. And it's
before we get into that.
Sorry, I got distracted. Back to me.
I want you to cook. Back to me. Yes. What do you think this is? An interview? Come on, no. Before you get into that, I'm gonna let you finish. But there's 2 new things related to database concurrency that have entered my sphere of I don't know, interest, experience, whatever. One is that one common complaint that I get now with the introduction of virtual threads in Java is that it's very easy to handle more web traffic than the downstream database can handle, because it's possible to create many times more threads and do work concurrently in the web server, but that you can't then send to the downstream database. And that might have something to do with the second thing I just learned, which is that Postgres, famous for its MVCC architecture, uses process concurrency for routing requests and resolving them against the actual data in the database server. Process, not even threads. Forget about virtual threads, processes. So anyway, I know what you're about to talk to has nothing to do with any of that, but yet when you talk about database concurrency, I think these things are kind of interesting. So anyway, carry on, go on. By the way, this guy said he learned distributed transaction management from your published content, which is cool. Like I assume he's talking about your discussions of saga patterns and the like. In the comment, I put it here on the screen right here, right? Learn distributed transaction management.
Yeah. No, that's cool. I mean, that is one of the other things I have is actually I created this in the middle of COVID when it's an online self-paced quote boot camp, series of videos and quizzes where you learn about the title is like distributed data management in a microservice architecture, which now 4 years later, I would call service collaboration patterns. So that's like how to implement sagas in a microservice architecture and how to implement patterns like API composition and CQRS for queries that span multiple.
Is it my Wi-Fi or You're kind of cutting out for me, and it could be me or it could be
Oh,
you. And I'm going to leave it to the audience to tell me. Somebody let me know, chat. Is he
yeah.
intermittent or is it? Anyway, I got the gist of it. Your sagas and service collaboration patterns is what you're titling, which I quite like. I'm gonna see that I. Can you hear me?
Yeah, interestingly, you had not cut out
Can you hear
until
me
now.
now?
Then you just cut out.
Mm-hmm. There you go. There you go. Can you hear me?
Yeah, yeah.
Okay.
The
Okay.
internet is like a series of tubes and pipes, and sometimes the tubes and the pipes, they get a little bit clogged.
Just feces. And most of it is feces. Did you hear like the whole that fight with Mike Tyson and the YouTuber? The Oh, somebody else says it's all good on their end. That's great. Okay, I'm color me confused. Anyway, it must be my fault, surely. But anyway, apparently it was slow and intermittent and barely working, not because of anything Netflix was doing. They were delivering and handling every request to the extent that they could. I mean, the request was satisfied at their edge.
Yeah.
But apparently, it was just the links of the internet itself were overly saturated, which is an
Wow.
interesting use case. You can't really fix the internet. You can't turn that off and on again.
Social media, it's a giant sewer, and down which an occasional nugget of useful information floats.
And then there's corn. Either way, it's not good. Okay, so anyway, you've got service collaboration patterns, and you've got this is actually a really hard thing to get right because, increasingly we're seeing people, even in the context of the modular monolith, which I'm quite keen on these days, right? I like microservices a lot, but even to the extent that you're building modular monoliths, there's a tension between modularity and isolation and the ability for me to build up a coherent but not too tightly coupled data model, right? So you still have to think in terms of this. You might as well have a network API boundary, when you start thinking like that, right? What do these patterns look like?
Yeah, I mean, it's interesting. Like, gosh, I mean, I don't know if we're going to go down into the weeds, but yeah, like in a modular monolith, it's like one of the issues you have is like, how modular should you go, right? And in particular, should transactions span module boundaries? And which in the most complex case could be deeply problematic, and you end up having to use the saga pattern inside your monolith. And then, which is something I find troubling, because a lot of the complexity of the microservice architecture is from having to use things like sagas. And so if you're using sagas in a monolith, you have the cost of microservices, in a sense, without any of the benefits.
Yeah.
So
right.
I wrote about this in, if you go to microservices.io, there's a series of blog posts like, how modular can you go? And one of them does talk about whether transactions should span module boundaries or not.
I don't think, I mean, I'm going to go with no. What do you think?
Oh, I would go, yeah, because otherwise it's just way too complicated.
Yeah. So you're going to say you want transactions across microservices? You're not talking about
transactions across
platform transaction manager. You're talking about Saga.
Yeah, transactions.
Oh, modules. Oh, okay.
Well, right. And except under some scenarios where you can have multiple transactions, but the collaboration is basically really simple. Well, you're frozen, man.
Yeah, sorry. Can you see me now?
Sadly, yes. Yeah.
Okay, good. Maybe if I stop my cam. All right. Okay. Let's see if that works. Can you hear me now? Just say sadly yes.
Yes, I can.
Yeah, okay. Okay. Maybe that'll. I think it might actually be my end. I don't know. I would tether, but I'm in Australia at the moment, which is which means if I were to tether, I would bankrupt myself. So I'm not going to do that. Anyway, yeah. So you're saying within a modular monolith, you would not, you would want to maintain transactions.
Well, yeah, I'd sort of prefer the
Issues that
transaction
you
per
kind of
operational
ineluctably will run into. Is that fair?
Yeah, I mean, because basically, you know, like one of the beautiful things about a monolith is you can use ACID transactions, right? Which is way simpler than any eventual consistency model. And so request comes in, you know, at transactional manages the transaction. All of the modules get invoked within the scope of that transaction, and you know, and you're done. And I think that's simple. And the more you get away from that, the more complicated it is. And then it's like, well, you're getting, as I said, the complexity of eventual consistency, which is without any of the benefits of a microservice architecture.
Yeah. I think to the extent that you're in the same code base, there's at least less redundant, sort of duplicative plumbing to set up for each new project. But I would argue you're right. That's a symptom of you shouldn't be optimizing for that. You should be optimizing for making that redundant duplicative plumbing very, very quick to set up and move past on each new project. And so, yeah, you're right. That feels like it would be redundant. So, okay. So the Saga pattern, for people who don't know, is that you've got this bookkeeper that keeps track of work that's ongoing, and that eventually will keep track of whether everything is sort of finished or not. And if something doesn't happen, then there's something that if it doesn't work, then there's something that creates a compensatory transaction, and that relies on something keeping like a transactional ledger of the work in the system, kind of like an outbox pattern with a catch, try catch block.
Yeah. Well, I mean, if I could paraphrase what you just said, right? So a saga is a sequence of transactions in multiple.
Just frozen. So frozen. Can you hear me?
Yeah, I can hear you.
Can you hear me?
Yes. Hello.
This is terrible. Okay, maybe you try turning off your camera. Let's see if that makes it go faster. Surely it's just voice.
Okay, where's my settings? Oh, yeah.
Oh gosh. Okay, can you hear me? So okay, what did you say a second ago?
Oh yeah. So a saga is a sequence of transactions in two or more participants, right? And then if one of the latest steps fails, then you need compensating transactions to undo what was done by the previous steps. And then there's a couple of different coordination mechanisms. So one, which is in a sense is what you're describing, is orchestration, where there's a centralized orchestrator keeping track of what needs to be done and telling the participants what to do. And then the other approach is choreography, which is where there is no central coordination mechanism, and each participant does something, updates its data, publishes an event which triggers the next participant. And that is choreography. And this, by the way, is one of the patterns that I cover in my distributed data management bootcamp, which right now I will say is available for one easy payment, $95.
Nice. Where do people go to get that? Is that chrisrichardson.net or something like this?
Yeah, chrisrichardson.net. But also on the homepage of microservices.io, there's a link to it.
Okay. I think I've done a good job of putting that up there. Yeah, there it is.
Yeah, I feel like I should say 3 easy payments of
$99.99. Exactly. Yeah. It's because it's not 100 if it's $99.99. That's cheaper. Does that work in other countries? Is that a thing?
Oh, you mean that kind of the TV commercials with free?
Yeah, I don't watch a lot of late night TV telemercials at 2 a.m. in like France or whatever. But I don't know. Does the mental trick of calling something 99.99 as opposed to 100 0.0? Does that actually make it more
I would
appealing?
not be surprised if that's widespread. Just on watching commercials around the world in languages that I do not understand, but they seem to have the same vibe as say American commercials or British commercials.
Oh, that's so sad. That's so sad. Well, we're number one in commercials, number one. Okay. Well, anyway, so that's microservice.io. That's your distributed data patterns thing, and
Yeah.
that's not the same as this O'Reilly thing we're talking about. What is that?
Yeah. Oh, and it's, by the way, it's not an O'Reilly thing. What I'd mentioned to you was my Manning Live project.
Oh, Manning. I'm sorry, I got that wrong.
So yeah, so for anyone who's listening, right, live projects are these sort of kind of like code, well, it's essentially very hands-on learning experiences where you solve problems by, in my case, writing a bunch of code or configuration. So you're kind of working towards a goal in a very practical way. And there's a whole, and you sort of learn by figuring things out.
Yeah.
So you get a series of instructions, do X, do Y, do Z, and then you have to figure out, oh, how do I do X? And you have to go search through some learning resources. And so it's a very, a hands-on learning experience. So what's just come out is this live project series, which is all about how to deploy services, as in services in a microservice architecture on Kubernetes.
Ooh, fun. Wait, so I'm looking for this. This is Manning. Kubernetes, is that like where 80% of the configuration and code written in the series is done?
Yeah. It's kind of funny, a lot of it. Yeah, I mean, when I say writing code, it's actually writing quite a lot of YAML.
Yeah, well, at least I understand it. I mean, having somebody like you break it all down would be really, really valuable, because, well, honestly, I don't think if you could commoditize, have no struggle through that effort and make it so that we can just learn from you and skip straight to the value and skip past all the tedium. That's good stuff. Do you teach people like straight YAML and then show them things like config or other ways of packaging up?
Yeah, I mean, so like the starting point is how do you write like sort of the basic YAML to just take a service, a container image and run that. So the usual deployment and service manifest, right? I mean, the interesting thing is you're running Kubernetes locally using Kind, which runs Kubernetes in a Docker container.
Yeah.
That's live project number one, and then live project number two is actually packaging services as Helm charts.
Oh, okay. So you do charts? Yeah, that's what I was asking about.
Yeah. So, and Helm, for anyone who's listening, is the Kubernetes packaging mechanism. And then step 3 is actually how to do GitOps, like a fully automated deployment pipeline using Flux CD.
Oh, I love Flux. Yeah.
Stuff. Which is
and that's from our friends over at Weaveworks, right? Well,
yes,
I think
but
now defunct Weaveworks, right? Are they still in business? I thought they shuttered.
Well, the Flux continued. I mean, Weaveworks sadly is no more, but then the Flux project continued. Yeah.
One of those vibrant open source projects. I'm just speaking to the company.
Yeah, and it got picked up. I believe it got picked up by some other company. And so that's very cool where, essentially you have a bunch of configuration, as in yet more YAML files in Git, and those YAML files specify which versions of, what Helm charts to install on your Kubernetes cluster. And Flux makes sure that, I mean, it applies the GitOps principles. So Git defines the state of your Kubernetes cluster, and Flux makes it true. So when you commit a change to the config, Flux then applies that change to your Kubernetes cluster.
Now, what always sort of baffles me about that is that the whole point of Kubernetes is I mean, it's got reconcilers. That's the whole point, is that you're supposed to be able to tell it what I want, and it's supposed to make it true. And so why do we need the thing on top of Kubernetes? And the reason we need that is because Kubernetes oftentimes has unpredictable semantics around making it true, right? This sort of paves over a lot of that and makes it actually.
Yeah, but it's sort of like how you tell it what you want by default. I mean, the built-in mechanism is like running kubectl, right? I mean, it's actually doing something on the command line.
Yeah.
Where Flux is saying GitHub defines the state of my Kubernetes cluster, and it figures out what when you do a git push, it figures out how to make the Kubernetes cluster match the spec, right? Match GitHub.
But what I'm saying is, it's not just doing it's not like there's just something git cloning or monitoring your Git repository and then just doing kubectl apply. There's all this other stuff like
I
mean, versions of the package.
Yeah. I mean, there's tons of things in there, like it actually, among other things, which I think is really interesting, it actually monitors the registry for new Helm charts.
Yeah.
And then when it sees one, it actually edits the manifests and does a git push, and then applies those changes into your Kubernetes cluster. So your say your dev cluster is continually up to date.
Which is nice.
Yeah.
And that's good, because I see a lot of people who are trying to do microservices, but they end up with 10 different folders with different projects in it, and they have to commit them all at the same time or whatever, and it just shouldn't be there shouldn't be one. For deploying 10 different things in lockstep is not exactly microservices, right? The ability to contribute and update the central build as necessary should just be independent of any artifact.
So I mean, for instance, one thing that's pretty straightforward to set up, right, is you make a code change to your service, you do a git commit, git push, that triggers the deployment pipeline, builds and runs the test for your service, and then publishes a container image and publishes the corresponding Helm chart. Flux picks up that change, updates the YAML in GitHub that defines the state of the cluster, updates the state of your dev cluster. Then once that Helm chart has successfully deployed, Flux can actually trigger an event which can then invoke a GitHub action that updates the manifest for your production environment, and then it could automatically promote that newly tested Helm chart version into your production environment, possibly along the way running some tests, right? And and by the way, the other thing that can happen is using Flagger, which is another open source project originally from Weaveworks. You can do canary releases. So you can safely and reliably apply updates into your production environment.
How do you know what safe means in that context?
Well, I mean, I guess
no outages.
Yeah. I mean, number one, right, is you're only deploying things that are truly tested, right? And then say with your canary release mechanism, you're essentially further verifying correctness during the rollout process. So instead of directing 100% of production traffic at the newly released instance version of your service, maybe you just start off with 1%. And then you gradually migrate more and more production traffic over while monitoring and managing that new version.
Right. And when you talk about rollout here, you mean actual rollout as opposed to Kubernetes deployment rollouts, like Kubernetes rollout, restart, and all that kind of stuff.
Yeah, yeah. I mean, you actually have two separate deployments, like the V1 deployment, the old one, and the new one side by side. And then sitting in front of that is some intelligent traffic routing that's implementing rules like in the beginning, all the 100% of the traffic is going to version 1 and none to version 2.
Yeah.
And then those rules are getting updated and you're progressively shifting traffic to the new version while monitoring, and Flagger is monitoring the metrics to make sure that version 2 is not exhibiting any sort of bad behavior.
So who provides this load balancing, this intelligent routing?
Flagger supports a variety of options. In the live project, I picked Linkerd, which is a open source service mesh.
Yeah. Okay.
Though
cool.
a simpler approach would have been to use something like Ingress Nginx. Because Flagger works with that one as well.
Okay. I mean, so at least you have options, right?
Yeah. And it's I mean, you have. I mean, if you go read the Flagger docs, it supports a wide variety of traffic routing mechanisms.
Nice. We should get one in Spring Cloud Gateway.
What's that?
We should build one in Spring Cloud Gateway. I wonder what that would look like. Wouldn't be hard, I reckon.
Yeah. This is kind of interesting.
Yeah. So, okay.
Yeah, and then I should say, so then the last live project, which is actually such a really interesting one, is up until now, everything I talked about is like running locally on your laptop, right?
Yeah.
With like kind clusters. But the fourth and final live project is making it work on, is setting up a AWS EKS cluster.
Oh, nice.
Which is, I must say, it's like kind of painful.
Yeah.
It's like, what the heck? This is managed Kubernetes? Seriously?
Yeah, I don't look. It's still better than hosting it yourself. I get it, but I've tried all three. I tried Azure. I tried Amazon. I tried Google. I quite like GKE. It's in terms of like hosted cloud provided Kubernetes distributions. It's got some batteries included. It seems to do okay. They even have this autopilot thing, so it's sort of even adds nodes to the cluster for you automatically based on demand. It's pretty good. I don't know if I had any issues actually. That was actually smoothest I've seen of the big three, of those three options. Obviously, if you are trying to have more control over the thing, you might well use a managed cross Kubernetes cross-plane sort of thing, like what we've got it. They give big old Broadcom range, but in terms of just getting up and started up and running, it's not bad.
It's interesting. I mean, I guess I've just tended to focus on AWS. I haven't had the brain power available to learn some other cloud technology. So, I mean, the good thing is that I figured out a bunch of stuff, and it was kind of painful in the process. And so, hopefully, if you follow my live project, it will be less painful for you.
This kind of stuff is super good because it's the Christmas season, and you could give the developer in your family and in your life the Christmas surprise to remember.
Absolutely. Yeah, and you can find all of this on Manning.com, and it's available for a pretty low price, actually.
Of $99.99?
It's not, something like that. No, I think it's probably like $49.99.
Okay. Don't quote either of us. We don't know anything here.
I'm just making this up. But
we're just talking heads on the internet, and you can't even see the heads, so we don't need. This might be an AI at this point. We don't know.
Yeah, we've been cloned. Our voices have been cloned. Really.
Yeah, exactly. trust nothing, except that you can learn to deploy microservices systems to Kubernetes, which is, it's, look, microservices are hard enough. Then Kubernetes being a very low level sort of distributed system makes it all the more cantankerous. So really having the skills to navigate that, I think, is really valuable. And this is a developer focused thing, right? I insist, I hold true that every developer should learn how to do this at least once. Just get it right once, so you know what you're dealing with.
Well, it's very true.
Right.
Like, I mean, I am a developer, right? And you know, and I'm not like an ops person, and sort of ops people they're sort of, you know, that's a whole different world. And so the way I'm coming at it, as I'm a Spring developer, you know, how do I get my stuff to run on this using this Kubernetes, YAML, Terraform, AWS technology?
Just throw some MongoDB in there and it's web scale. It'll be fine. Gosh, are you using a SQL database, or like have you gone?
No, the example. I mean, actually, it's funny you should mention that, because so the AWS the sample application, I should say, just uses a Postgres database.
Nice. Is it RDS or do you host it itself?
Well, that's the really interesting thing, right? So on AWS, it would obviously make sense to use RDS. And so part of the Fourth Live project is, instead of up until prior to that point, right, it's just been the database has just been a Kubernetes provisioned one, right?
Oh,
but
right.
But then in the Fourth Live project on AWS, it's like, how do you provision an RDS instance?
Right.
And then
go on.
Go on.
Well, do you talk about database migrations and like when you roll back when you do your Canary thing and you have to roll back or roll forward rather? Do you talk about how?
No, that's interesting. No, I haven't. I don't touch on that database side, that particular database topic.
Yeah.
So I suppose I'm looking at the sort of the infrastructure stuff you have to deal with. But that's an excellent point. And what's interesting, like on AWS, right, you could say, okay, how am I going to deploy my RDS instance? And one option, right, would be to say use Terraform to provision, but then provision the RDS instance. But then the other option is I came across this fascinating open source project called Crossplane, which apparently it's so funny. You go read the website, it talks about control planes and how important they are. And as a developer, it's like, I have no idea what a control plane is. But once I got beyond that control plane, blah, 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 essentially, right, Kubernetes manifests that provision cloud resources. So you can just write it extends the Kubernetes API, and there's basically like an RDS Postgres instance. Kubernetes resource. And so it's just yet one more YAML manifest to deploy your service, say in the Helm chart, and it automatically provisions the RDS instance as well.
Oh, that's a separate project from. It's not from Amazon. It's a separate open source thing.
Yes, yeah, and I think it's a multi-cloud thing, but the idea is you write Kubernetes YAML files so it's in the Kubernetes universe that actually provision things in the cloud universe.
Oh, that's super cool. Because I'd be like in GKE, they have Google themselves furnish Kubernetes objects. So I've always done that. I didn't know there was like, oh, look at that. Okay, that's really cool.
I didn't know that there was something in the Google one.
Crossplane.io. Here we go. Oh, that's so good. Because this, I do not like. Look, well, first of all, you said Terraform, but when you said that, I heard, well, what about Pulumi? What about Jenkins? What about Ansible? What about CloudFormation? What about Puppet? What about Chef? What about Salt? What about Open? What's the quote unquote open alternative to Terraform that somebody forked or whatever. What's the open?
Yeah.
Like,
I mean, there's the tofu. Is it open
yeah,
tofu?
open tofu or whatever, which is, you know,
I mean, this is a trouble in this space, right? Where
so if I can just stick to Kubernetes, I'm happy.
if I pick X, then there's going to be a whole bunch of people saying, well, what about A, B, C, D, E, F, right?
Exactly.
So it's
For me,
like, so I just picked Terraform because that's the one I know. And I'm assuming whatever I did would work in the fork of Terraform. I've not actually looked at it. And then, but it's, oh, okay. But it's like, just pick, but you know, there's a whole bunch of concepts here, and yeah, maybe you need to adapt them to whatever technology you're using, but it's like, learn the concepts first.
Well, no, that's why I like what you just mentioned, the crossplane, because that, like, at the end of the day, as long as you know how to use Kubernetes, you'll have the solution, right? Like that's nice to know. And there is and that actually speaks to what I was talking about earlier. Kubernetes even has a reconciler. That's the whole point. It can, why not let it do that for you, right? Let it reconcile your infrastructure, even if that's, you know, cloud managed infrastructure. It can do that for you.
Yeah.
Ooh, look at this.
Oh, it's an interesting comment there. Yeah.
Yeah. Very nice. Look at that. Chat coming in real clutch right now. Pretty great. Pretty great, if you ask me.
So I kind of like it. Like, actually, in the live project, I use Terraform to provision a AWS Kafka cluster because I sort of view that as service-wide infrastructure, whereas the service-specific resources, like a database, kind of made sense for them to be provisioned using Kubernetes manifest, which could potentially just be part of the Helm chart for that service.
Yeah. Nice.
So that was kind of the decision now making process I use to decide what to do with Terraform and what to do with like crossplane.
I gotta watch your training. Clearly, I mean, just every sentence you've uttered so far has been really, really good. And that's not even what I wanted to talk to you about, though. I dragged you onto this show. I'm using air quotes here, but people can't really see because, well, there's no camera. Anyway, I dragged the air quote show because I saw this talk you're doing, calling. Okay, what is it called? What is ISAQB, by the way?
Oh, that's a really hard to remember acronym for this International Software Architect something or other. So it's actually an organization in Germany in the realm of software architecture. And so sort of from my perspective, what it's all about is once a year, they put on this conference called the Software Architecture Gathering. And I spoke at it during COVID remotely. And then this year I went to sunny Berlin in November.
Oh dear.
Actually, that was a joke. Yeah, I didn't see the sun.
I know. It's freezing and cold.
But I still had a good time. And actually, it was beautiful. I stayed right next to this park where all the leaves were like gradually falling off the trees. And it was just beautiful, absolutely beautiful there, even though there was kind of like minimal sun. Yeah, anyway, there was this fantastic software architecture conference that, I spoke at and I participated in a panel.
And what is so you have a talk. So the talk panel topic was enabling DevOps and team topologies through architecture, architecting for fast flow, or was that a talk that you gave standalone?
Oh, that was my talk. Okay. Yeah, that was just like architecting for fast flow.
I just had do you know Luke Shannon? You probably do.
The name is familiar.
Yeah, I just had him on the show yesterday, I think. And there we talked about using things like developer portals as a sort of shared integration hub for developers, right? For the strata of knowledge that an organization builds up and that needs to be surfaced for people to be able to iterate more confidently, And is that to do at all with what you're talking about, not having seen your talk?
No, um, no, except that it's sort of, you could say it's kind of adjacent to it, right?
Okay.
So it's sort of like, I mean, in a way, this is a topic that I've actually talked about in various ways for some time. And it's like the whole kind of like the argument is this, the world is this crazy volatile place, right? And in order for businesses to thrive, they need to be much more agile, nimble. And given that software businesses are powered by software, IT needs to deliver software much more rapidly, frequently, and reliably than they've ever done, right? And
Right.
and kind of a better way of, or maybe a more modern way of expressing that is you need fast flow, where IT is continually delivering a stream of relatively small changes to users, right?
Yeah.
And that's so it's sort of, and so that's the fast flow concept, right? And how are you achieving that, right? So that's through DevOps as defined by the DevOps handbook, along with an organizational structure, specifically team topologies, right? Like a loosely coupled network of small, long-lived cross-functional product teams. And then on top of that, you need an architecture that supports it. And so that's sort of the big picture. And I've had, I mean, what I just described is the success triangle, which actually was in my microservices patterns book back in 2018, but it's still very relevant today.
Right.
So that's kind of like, and today the phrase fast flow is quite, I mean, that's kind of the term that people are using today. And as I said, that's a combination of process, namely, and organization plus the supporting architecture.
Is this the whole microservices as a reverse Conway maneuver?
Yeah, I mean, it's yes, but it's sort of, but in a more general sense, right? So you need an architecture, and then it's like, what are the characteristics of an architecture? And it's like the architecture needs to be loosely design time coupled. So in other words, teams can work on their part of the application independently most of the time, and they're not creating work for other teams, and they're not needing work to be done in order to complete their work, right?
And that gets into a discussion of modularity or domains or context or whatever. But
so you need modular. Well, you need loosely design time coupled modules that can change without impacting other modules regularly, because the opposite would be tight design time coupling, where I change my stuff and then I have to meet with you to change so that you can change your stuff, and you probably have to meet with 3 other teams, and then as a result, to make one simple change, it takes forever.
Right.
As is quite typical in many organizations, because they have tightly coupled architectures.
Right. Yeah. Which goes to show you yet again that the worst part of technology is people.
Well, they tend to mess things up. Yeah. Should probably turn me on so you can see my face, actually. But but it's like, please adopt an idea that Parnas talked about, namely modularity. He wrote about this back in 1972. So it's about damn time that people kind of fully embrace loose design time coupling.
Right.
And then the other part of it, you could essentially say, is you need a fast deployment pipeline.
Right.
And there's sort of 2 parts to that. One is, which I could refer to as test. You need, and it's actually some aspects of the fast deployment pipeline are a function of applying kind of suitable build technologies and clustering and all of that. But then there's a major architectural component to that as well. So your software needs to be testable using automated tests. We also need to write automated tests. Those tests need to execute quickly. And then the deployment pipeline needs to actually scale to support the volume of the commits or pushes that are coming out of all of the teams, right?
Right. And this gets me into, at scale, you start to get into, there's sort of knock-on effects here. And I've seen some really, like testing in particular, the sort of verification of the code that you're deploying, that whole thing, I guess you'd call that testing, right? But that whole area after it's compiled and committed and into a CI pipeline, you get into sort of, well, okay, do I have to run every single test all the time? So you got things like Gradle's, Gradle Enterprise, what it used to be called Gradle Enterprise, now they call it Develocity, where they can do smart selective test running because they can figure out based on what you've changed, what tests are likely to be impacted, or you get things like a scale. Can you actually generate these tests automatically? I think this is one of those key use cases for AI, where I can actually have the AI basically look at my code and go, okay, this is something that might need a test, and that does not a great job, but it does a job. It gets you somewhere, like you have to scale up just that part. It becomes its own little space.
So in a sense, right? And then there's actually the other part is deployment, right? Your deployment needs to be fast and automated. It needs to involve zero downtime, which is kind of impacts the architecture of your deployment environment. And then deployment should not be a bottleneck, right? Because you have another scalability problem there. And if you think about it, like, so if you just have one code base and one deployment pipeline, and your application continues to grow, you ultimately have a scalability problem, right? You don't have a problem when the application is small, but when the application is large, you have a scalability problem. And so one way to address that is by, throwing technology at it and selective test execution. And maybe that helps, maybe it doesn't.
Big maybe.
Or you actually reduce the size of the problem by breaking it up into pieces, namely a microservice architecture, right? Where you have multiple smaller code bases, each with their own deployment pipeline, and you no longer have a scaling problem anymore.
Right.
So that's sort of the kind of, in a sense, the big motivation for using the microservice, or one of the big motivations for using microservices is to solve scalability problems you could otherwise run into with your deployment pipeline.
But this is, when you say scale, you're talking about as an organization of people, not just a runtime performance application concern, but scaling the code base, scaling the team, scaling the organization.
Yeah, right. And because if you think about but maybe a bit of context here, right? So part of, say, DevOps is continuous delivery methodology, where essentially every developer should be committing frequently. So if you have 200 developers on your team, right, as was the case, like client I was talking to last week, if they're committing every day, right, that's a high volume of commits, right? And, if you think about, let's just say there's an 8-hour workday, and you divide, and how many commits per hour is that, right? And then, it's quite high.
Right.
And then, your deployment, to build and test your application is going to take some time. And, and it's you end up to, probably your deployment pipeline will become a bottleneck, or you end up batching changes together and building and testing and then deploying batches of changes, which then make troubleshooting harder, right? Oh, here's like 20 commits. which one of them broke production, right? Whereas if you've got, a single commit flowing through, it's pretty obvious which one of your commits broke production.
Right? You can see, you can bisect it.
Yeah. So anyway, that's kind of like, so that's the scaling problem that I'm talking about, not the scaling problem at runtime.
Right. Yeah. No, I just think it's very interesting that there's all this other stuff that you should care about long before the program is actually running,
Yeah. Well, one of the interesting aspects of software architecture is, in a sense, an architecture solves it's almost like two sets of users in a sense.
Yeah.
It obviously at runtime, it's solving the needs of the true end users, right? And there you're thinking about kind of runtime non-functional requirements like scalability, availability, performance, security, blah, blah, blah. And this in a way is maybe what makes software different, is it's the other type of users, or people or stakeholders the architecture needs to support are the developers, right?
Yeah.
Your architecture needs to the architecture needs to make it easy for the developers to make changes.
You got to optimize for. That's the whole point of architecture itself. It's the optionality, right? Your constraints inform architecture, and architecture provides optionality. You choose what things you want optionality on, and you choose the architecture accordingly.
Yeah. Well, that's you're channeling Gregor there by any chance?
I'm sure there's some of that. Yeah.
But it's like, like you think about traditional products which are manufactured, right? You build something, what you've built doesn't impact how easy it is to continue to modify and extend it, right? It's like you just kind of you manufacture something and you just release it. Whereas the design decisions you make today can actually determine how easy it is to make changes tomorrow.
Yeah. Right.
And so
this is why a little bit of upfront design is never a bad thing. A little bit, not always.
Yeah. So many of the goals to do with the microservice architecture are actually to enable development to be easier and faster, or to use the terminology from my talk, right? It's to enable fast flow. But having said that, the monolithic architecture can be a perfectly good choice for
maybe
up to a certain size and complexity, and organizations of a certain size and certain size as well, right?
Right.
So like in the presentation, it's like, okay, here's the whole thing about fast flow and the architectural requirements. That's part one. Part two is basically talking about modular monoliths and how they can satisfy fast flow.
I love this.
But then with the idea that ultimately you are most likely going to outgrow your modular monolith, and then you have to adopt the microservice architecture.
Yeah, and if you build accordingly, I don't think it has to be that. It doesn't have to be that painful to move to that architecture if you start building modular monoliths from the get-go, right?
Yeah. Yeah. Well, it's funny, right? Remember we had the little discussion at the beginning about transaction boundaries and modules, right? So I guess you could say there's a flavor of modular monolith, which is a microservices ready modular monolith, right? Where transaction boundaries are scoped to a module boundary. And then you could say modules communicate in a way that is, quote, network friendly, with the
Right.
idea that when you want to, you can just pull one out.
Yeah. Just drag the package into a new Spring Boot project.
Yeah, but then to sort of revisit the comment I made at the beginning is that bothers me, because I feel like to actually have a microservices ready monolith, you're basically incurring a lot of the cost and sort of complexity of the microservice architecture, namely the fact that you might actually have to use sagas or more generally eventual consistency in your architecture, without any of the benefits, right? Because you've got microservices style eventual consistency, but in a monolith, and that I don't know if you really want to go down that path.
I feel like it's easier to embrace that little bit. I think there's a gradient between full-on distributed systems and a monolithic application, and sort of it's a little bit more work to make it a modular monolith, but that work will lend itself, because you get a lot of benefits by doing a modular monolith. Like you said, for a small enough team, it can be quite nice. You get you can share types in the class path, you can get compilation errors, you get all that sort of fast velocity. But if you're then doing things in terms of event-driven architecture, which, nothing wrong with that, right? You get a lot of benefits, I think. I don't know. It just seems like it's not as easy as per monolith, but it's a little bit harder.
Yeah, I don't know. I kind of hear what you're saying, and it's like one of the issues you have is like, oh yeah, we can just use events between our modules, right? And maybe the framework abstracts away a whole bunch of the complexity. Mm-hmm. But I still feel like, the simplest possible thing you can do is like a method call where A calls B, right?
Yeah, sure.
That is so dead simple. And I feel like we as engineers kind of get too carried away and come up with these overly complex, over-engineered solutions that don't kind of help as much as we think they should, right? Because in particular, right, we're going to go, we're going to build this microservices ready monolith, and then who knows whether you're ever going to extract out any services, right? You're incurring a cost today for something that may or may not actually become true in the future. And then who the heck knows whether the module boundaries actually map neatly to services anyway. So it's sort of this kind of over-engineering and speculative development is highly questionable.
Yeah. I mean, if you know it's going to stay small, do whatever you want. But you're going to have to, if you're going to go to a microservices architecture, you're going to have to do the you're going to have an iteration of the code that looks like that modular monolith version. That's all. If you're going to, that microservices are where you're going, start with the modular version, and then it should be pretty easy to tease it out. But yeah, okay. If you've got like one package worth of interesting stuff happening, and I can see what you're saying.
But I guess it's my point being is you don't know whether microservices is what it, unless someone out there has invented crystal ball technology, right? You actually don't know what you're going to need, right?
Of course.
The original idea is the world is volatile, uncertain, complex, and ambiguous. You really don't know what the future holds.
Yeah. 100%. 100%. Start small, and if you need to, get bigger. More modular, though.
And I feel like solve today's problems, in the simplest possible way. And then like tomorrow comes and things need to be more complex. Solve those problems tomorrow, not today, right?
Yes. Agreed. Okay, so this is a microservices.io and then chrisrichardson.net. I've got the virtual boot camp distributed data management on chrisrichardson.net there. Got the microservices IO sort of with a link to your slides there. This is the thing you might go to for some Kubernetes objects. That's nice. And here is the Manning, a link to a thing that'll describe and make easy to get access to the Manning Live projects on deploying microservices via.
Yeah, and I would say, it makes a perfect.
What else? Where, if you, I mean, are you on? Clearly, you are on the internet, and with those links, I can assume that you want to be found. But where else should people go to find out about more about you, my friend?
Oh, I think these are pretty good. You pretty much covered them. I guess the only thing I point out is I guess I'm trying to move away from Twitter.
He turned on his camera. My data is not good.
Okay, I turned it off. That's interesting. The camera does bandwidth. Can you hear me now? Can you hear me, Josh?
There you go. Are you there?
Yeah.
Oh boy. Okay. So what I got, my internet took a nosedive. So clearly, based on these links, you're online. Where else do people go to find out more about you?
Oh yeah. So I've been trying to move away from Twitter. So you can find me on Blue Sky.
What's the Blue Sky URL? Is it chrisrichardson.net?
It's like C Richardson. Yeah, no, it's just the .blue sky or whatever the default domain name is.
Okay, so Chris Richardson, C Richardson. Let me find you there. There we are. C Richardson, C Richardson.bsky.social. So put that in there and there.
Yeah. I mean, there seems to have been in the past month a big movement there. Although mostly people seem to be following one another, and at least out of the people I follow, there hasn't been a whole lot of content.
Yeah. I mean,
but you got to start somewhere.
Yeah, I quite like it. I like it. It feels a bit like classic Twitter, from 2010. Before the I mean, even Twitter like 5 years ago, was not great. So I'm really happy to sort of get this more. It's just faster. I mean, it's just everything loads faster, if nothing else. There's just fewer moving parts in the UI, so it just moves more quickly.
And then also on LinkedIn as well. I feel like the best places are. I think the best places in a way is actually LinkedIn these days.
Yeah, it's really good. Let me see. What is your LinkedIn URL?
Oh, it's like my ID is Pojos. Oh yeah.
Really?
Yeah,
LinkedIn.com.
Yeah, LinkedIn.com/in/Pojos.
You're kidding. You're not. You're not kidding. It's right there. I found it. Oh my God. That is so good. Okay, here we go. Pojos. That's a plain old Java object.
Yeah.
For the kids who don't know. There you go. Oh, one last question before we hit the road here.
Oh gosh. I find Growl really interesting. On the one hand, I kind of get it, but on the other hand, what it troubles me that it takes so long for Growl to actually build an image. And I mean I kind of joke about it feels like Bitcoin mining or something like that. So I'm sort of a little reluctant to want to use Growl in like a deployment pipeline just because it slows things down. And then I would always worry about it deleting some of my code, right? And actually, I take Java code that is working perfectly, run it through the Growl compiler, and then maybe it might delete part of it. And then I've got an application that perhaps I need to test thoroughly at the end of it. And that I find very disturbing. So I kind of like, as I said, I'm not exactly a fan of putting Growl in my deployment pipeline unless you have a use case that can truly benefit from the efficiency gains. And okay. I know it's the hot thing, and I'm being somewhat of a heretic, but that's my 2 cents.
I appreciate it. Okay, my friend, I need to go get some coffee and line up for the next interview. And so while I love this conversation. This is the kind of stuff you can get if you go to microservices.io, chrisrichardson.net. There's a virtual boot camp that, by the way, it's what is that URL here? It is, I actually looked at it. I actually looked at the prices here. It's a second. Here we go. For those who are wondering, come on, where did I find it? Training services, that's separate. There's microservices.
Yeah, it's like microservices.io. No, sorry, chrisrichardson.net. And then
for consulting, Chris Richardson. But there's a signing up for a 2-hour highly focused consulting session. You could do that. Remote office hours. Yeah, that's all good. Like this is your, trust me, you want to talk to this guy. He's got really, really good this has only been an hour and we've got a whole bunch of different things I want to sort of see too. So I really appreciate you taking the time, my friend. As always, you're a legend. Here we go, putting that right there. Go there. That's if you want to talk to Chris directly for a little bit, well worth your time. But that wasn't even the link I'm looking for. The link I'm looking
thank you for promoting that.
No, thank you. Are you kidding? It's great. Oh, this one. I found it. The Learn More virtual boot camp. Did I link to this already? I think I might have.
I think you did.
It was not that. This is really okay, $395 a person, but there's a coupon for $95. It's not even $99.99. It's $95 flat. So
yeah, it's only one easy payment.
Add this. Here we go. Putting that up there as well. There you go. This is it right here. Go get this. I'm gonna go get this too for myself because I want to learn more. As always,
I want to thank you for inviting me, and I thank everyone who's listened to our random ramblings.
Yeah, thank you everybody, and thank you, Chris. It's been super good to see you. I'm Merry Christmas, Happy Christmas, as they say in the UK, and Happy New Year to you.
Yeah, same man. Good chatting.
Bye, everybody. Bye.